Okay, apparently people are getting sick of the puns in the videos, so I decided to tell a real story. When I was in 8th grade, I wanted to go out for track really badly, but I was a distance runner, and we had tons and tons of good distance runners in Lennox. So I wanted to run hurdles, the 200-meter hurdles. But I realized as I ran the hurdles that I had an incredible fear of jumping over those hurdles, that I was going to hurt myself. But then I got over it. Still, I'm hoping at least one person laughs. Anyway, we're going to be working on 9.5, solving quadratics by graphing. Now, there is nothing new in what we're doing today except the solutions to the problems. Okay? So I'm going to make sure we get this video done because Michigan State's playing St. Louis right now, and I really need State to win. Alrighty, the answer for any quadratic graph will be the zeros. Okay, those are the y-intercepts, or where y equals 0. That's the solution, okay? So the answer to all of these will be something in the form, my pen froze up here, will be something in the form x equals 1 and x equals -1. So that's the solution to our graph, okay? So as we graph these, we have this equation here. Now, once again, to graph it, we need the values of a, b, and c. My value of a is 1/2. My value of b is 0 because there's no x term in here, and our c is a -8. Okay, so that means we do opposite b over 2a to get my vertex. Well, my opposite b is 0. My 2 times a will be 1. So my center of my table is going to be 0. So let me make my graph here. So center 0. That means we'll go 1, 2, -1, -2. So here if I plug in 0, I'll get -8 for my y value. My 1 here will be 1/2 minus 8, so that would be -7.5. And my 2 will be 4, so it would be -6. So we get -7.5, -6. So I'll insert my graph. And I'll graph this here. So we'll get 0, -8. 1, 2, 3, 4, 5, 6, 7, 8, -7.5. And -6. So here's our problem. We just talked about in the last picture that the answers are zeros where they cross the y-axis. I don't know where it crosses the y-axis yet. So that means my table, while it looks really nice, is not good enough. I have to add in another value. So here I'll go 3 squared is 9, 4.5. That means I'll get -3.5. Okay, we're still not there, so we got to do a 4 now. 4 will be 16. 16 times 1/2 is 8. And finally, when my y is 4, the value is 0. So my 3 will be here, and my 4 will finally be the 0. And this side, because the axis of symmetry, it's right down the center, will be there. So I got my quadratic forming like this. And my zeros, whoops, right through there. My answer is x equals 4 and x equals -4. And when they say in a problem, check your answers, and they'll say check your answers algebraically, what they mean is they want you to plug these numbers back into this equation. So they'll want, 1/2 times 4 squared minus 8 equals 0. Which it does, so you put a check mark and you do the same thing for -4. So when they say check answers algebraically, they just want you to plug it back in. Okay, so now that was kind of a long process there to graph it. Okay, what if we wanted a calculator? Now, before we can graph this, we need to find the values of a, b, and c again. But the problem here is that the equation does not have a 0. So that means we have to actually subtract the 6 to both sides to get x squared minus, and I'm going to put 1x to do Ann's method, minus 6 equals 0. Now we can do the values of a, b, and c. A is 1, b is negative 1, c is negative 6, and so on and so forth. Now, if I wanted to graph this, I'd pull out the calculator, and I would say 1x squared minus 1x minus 6 equals 0 or y. They mean the same thing. And I'd go zoom standard. Lo and behold, there's my graph. Now, you can do two things. You can either pull out the table and write that down, which is totally fine, and it will give you the zeros. Or you can go second, calculate, and we've done this before. They have the 0 thing in here. So when they say left bound, you'll need to go left of the 0, which is here. Right of the 0 will be here. And then there'd be the middle. So this time you can't push enter, enter, enter. But we know one of the zeros is x equals 3. And the other one from, if we did the other 0, so we're going to the other side. Left bound will be to the left, which is up there. Right bound will be right there. Our guess is right about there. And this is x equals negative 2. And whenever you graph it with a calculator, I want you to then sketch your graph to show me what it kind of looked like. And it kind of looked like that. Okay? So, in order to get to the zeros button, you'll need to go second, calculate. Okay, once you're there, you then get, and then you get to 0. And then you have to go left bound, right bound. It just means go left of the number, go right of the number, and then solve it. And the reason why you have to do that is because there's 2 of them. So you got to tell the calculator which it's looking for. Okay, how are we doing on time? Not bad. So here's what I want. I want you to graph this by hand and then check with your calculator using that zeros function. Okay? Before you start, though, you need it to equal 0. So you'll need to move that too. Okay, so give it a try. Alrighty, let's see how we did here. Excuse me. So we got to move the 2 over. We got to subtract 2 from both sides. I hate when that thing does that. Okay, so we get negative 1x squared plus 3x minus 2 equals 0. Whoops. Values of a, b, and c here. Negative 1, 3, and negative 2. So our b value is going to be negative 3 over negative 2, which is 3 over 2, or 1.5. So I make my table. My middle, then, is going to be 3 halves. First number to the left of 3 halves is 1, then 2, then 3, and 0. So if I plugged in 3 halves, this would be a good time for a calculator. I'm going to use the store function. So I'm going to go 3 halves, store for x. So I'm going to go negative 1 x squared plus 3x minus 2 equals 0.25, math, enter, enter, 1/4. If I plugged in a 1 here, I would get negative 1 plus 3 is 2, minus 2 is 0. That means this is 0, and if I plugged in 0, I'd get negative 2 and negative 2. So then I'd graph this. I'm just going to sketch this one. 1, 2, 1, 2, So 3/2 would be here, 1/4 would be right about there. 2 is there, there. -2, -2. So there's my sketch. My zeros appear to be x equals 1 and x equals 2. So let's use our calculator and check. So I'm going to go y equals -1 x squared plus 3x minus 2. Zoom standard. That looks like the same graph. Let's check our table. That looks right. Alrighty, so there I checked it with the calculator, I drew it out by hand, and I got our answers right there. Alrighty. Here's the problems we're going to be doing tomorrow in class. Everyone have a great night.